Day 751 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1340, jump game 5. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given an array of integers r and an integer d, in one step you can jump from index I to index I plus 1 where I plus x, where I plus x is less than r dot length and 0 is less than x and s is less than or equal to d, or I minus x, where I minus x is greater than or equal to 0 and 0 is less than x and x is less than or equal to d. In addition, you can only jump from index I to index j if r of I is less than r of j and r of I is less than r of k for all indices k where for all indices k between I and j. More formally, the min of I and j is less than k, which is less than the max of I and j. You can choose any index of the array and start jumping. Return the maximum number of indices you can visit. Notice that you cannot jump outside of the array at any time. All right, y'all, so that may seem a little bit confusing at first. So let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input r equals an array of integers 6, 4, 14, 6, 8, 13, 9, 7, 10, 6, 12. D equals 2, the output is 4. So that means with the output is 4, that means the maximum number of indices we can visit when following these requirements right here is 4. We can't visit more than 4 indices if we follow those requirements. So let's go through the explanation to see what those 4 indices are and how we got there. It says we can start at index 10. Boom. So this index 10 right here, this is where we start, has a value of 12. So R of 10 would be 12. Boom. So this has a value of 12. Boom, it says we could jump from 10 to 8. So we could jump from index 10, which is this 12, to index 8, which is this 10. Now, it's important to realize when we jump, we can only jump down, right? Because that comes from this. R of I has to be greater than R of J, meaning we can only jump down. And R of I has to be greater than R of K for all indices K between I and J, right? So that's why we can only jump down, because I, which would be the starting index, has to be greater than J, which would be the index that we're jumping to. So we jump from 10 to 8. And when I say greater, we're talking about the values, not the indexes. These up here are the values, right? These numbers at the top represent these numbers right here. Sorry, y'all. Represent these numbers right here. And then each one of these indexes or numbers at the bottom represents the index of this. So this is index 0, this is index 1, this is index 2, and so on. So these down here represent the indexes. These up here represent the values in the array. So boom, once again, we can only jump down. So we go from 12 to 10. Boom, that's down. And we're able to make this jump because 6, which would be K in this case, is less than I, right? So boom. Because right here it says R of I has to be greater than K as well. So since 6 is also less than I, we could jump that, because remember, K is all indices between I and J. So in this case, this 6 would be K, but it works because 6 is still less than 12. So once again, we go from 10 to 8. Boom, now we're on 8. Boom. Then we go from 8 to 6. It says, so from index 8, we have 10. We go to index 6, which is 9. Boom. So we right now we're on 9. Now remember, we can make this jump because 7 is less than 10. The K, which is the indices in between I and J. So in this case, the indice between 8 and 6 would be 7, and 7 is still less than 10. So, and I'm talking about this 7, not this 7. This 7 is still less than this 10. So we can make that jump to here, to index 6. Then from index 6, we could go back to index 7, right? Because you can see 7 is less than 9. Once again, so this would be I, this would be J. I would still be greater than j, so we can make this jump. So we go from here to here to here. Once again, notice how it's like we're going down the steps. We can't go up the steps. And I'll explain that in the next part of the explanation. It says, note that if you start at index 6, you could only jump to index 7. You could not jump to index 5. So if we're at index 6, we cannot go to 5 because 13 is greater than 9. So since 13 is greater than 9, we cannot make that jump, but we can jump this way because 7 is less than 9. So once again, we can't go up. We can't go from 9 to 13, but we can go from 9 to 7. Boom. Then it says you cannot jump to index 5 because 13 is greater than 9. So once again, from right here from index 6, we cannot jump to from index 6, we cannot jump to index 5. Oh, sorry, we're right here. We cannot jump to index 4 because index 5 is between index 4 and index 6, and 13 is greater than 9. So we can only jump this way. We cannot jump from here to here, even though this 8 is less than 9. This 13 is in the way, and it's blocking this jump. Remember, we can't jump over. We can only jump. It has to. When we made this jump, we didn't have to jump over anything. We could just jump right here. But if we want to go from 9 to 8, we'd have to jump over this 13, which we can't do because all indices k between I and j, I has to be greater than k. So in this case, I is not greater than k, which would be 13. So we cannot make this jump to 8. Boom. Then it also says similarly, we cannot jump from index 3 to index 2 or index 1. So we also can't jump from here to here because we have this 14 in the way, right? We'd have to jump over this 14. We can't do that. So that's not going to work either. So just in case that didn't make sense, let's take a look at example 2. So in example 2, our input r equals an array of integers 3, 3, 3, 3, 3, d equals 3. The output is 1. It says you can start at any index you always cannot jump to any index. So no matter where we start, we cannot jump to any index because it says right here, I of r has to be greater than k, or r of I has to be greater than k, or r of I has to be greater than j. Sorry, y'all. It doesn't say greater than or equal to. It says strictly greater. So since these are all equal, then nothing is greater and we can't make any moves. We can only make one move. Boom. Then in example 3, we have our input r equals an array of integers 7, 6, 5, 4, 3, 2, 1, d equals 1. In this case, the output is 7. Explanation says start at index 0. You can visit all of the indices. So from here, once again, we could just move down because remember, we could jump down. We just can't jump up. So, and sorry, we didn't go over D, but once again, D has to be, what did it say? In an integer D, X has to be less than D. So whatever, we cannot take more than D steps. So since this case is 2, we cannot jump more than 2. We can only jump 2 at a time. That's all that's saying. So now that we, up to 2. We can't jump more than 2. We could jump up to 2. And here we could make a jump up to 3, but there's no need. Boom. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, first thing we need to do is we need to store the size of the array. So we're going to say let n equal r.count. Boom. And then we're going to create our memoization array, which will store the maximum number of jumps possible starting from index I. So we'll just declare a variable called memo, and we'll set that equal to an array. Open up the parentheses, repeating, colon 0, 0, comma, count, colon n. Sorry, y'all, that should be n. Boom. Now we're going to do our depth first search function, and this is going to return the maximum jumps possible starting from index I. So it's going to be some recursion inside the main function, though. We're going to say func dfs open up the parentheses, underscore I, underscore I, colon. That's going to be an integer. Come outside of that, it'll return an integer. And we'll open up the brackets. And if already computed, we're going to return the cast result by saying if memo square bracket I does not equal 0, then we'll open up the brackets and we will return memo square bracket I. Boom. Then at minimum, we can always stay at the current index so the result starts at 1. So we'll come underneath this, declare a variable called res, set that equal to 1. Then we'll try jumping to the right up to distance d, because remember, we can't make our jump greater than d. So we're going to say for x in 1 dot 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 d. We'll open up the brackets and we're going to calculate the next index. We're going to say let next equal I plus x. Boom. Then we're going to stop if we go out of bounds. The next value is greater than or equal to the current value, or if we go out of bounds or the next value is greater than or equal to the current value, because jumps are only allowed to smaller values. So we'll come underneath this and we'll say if next is greater than or equal to n, or two vertical lines for or r square bracket next, come outside of that is greater than or equal to r square bracket I. We'll come outside of that, open up the brackets, and we'll say break. Boom. Then we're going to recursively compute the best path from the next index and update the maximum result by coming underneath this, and we're going to say res equals max, open up the parentheses, res, comma 1 plus DFS, parentheses, next. Then we're going to try jumping to the left up the distance d. So we come underneath this for loop, start a new one. We're going to say for x in 1 dot 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 d. We'll open up the brackets and calculate the next index by saying let next equal I minus x. Now we're going to stop if we go out of bounds once again, or the next value is greater than or equal to the current value. So we'll say if next is less than 0, or two vertical lines, r square bracket next is greater than or equal to r square bracket I. Come outside that, open up the brackets, and we can break. Boom. Then we're going to recursively compute the best path from the next index and update the maximum result by coming underneath this and say res equals max, open up the parentheses, res, comma 1 plus DFS, open up the parentheses, next. Then we're going to save computer result in a memo array by coming underneath this, and we'll say memo square bracket I equals res. Boom. Then we're going to return the maximum jumps from index I by coming underneath this. We're going to say return res. Boom. Then we're going to track the best answer across all starting indices by coming underneath this. And we're going to say declare a variable called max visited equals 0. Boom. Then we're going to come underneath this and we're going to say for I in 0 dot dot less than n. We're going to open up the brackets and we'll say max visited equals max, open up the parentheses, max visited, comma DFS, parentheses I. Boom. Then we're going to return the maximum possible jumps overall by coming underneath this, and we're going to say return max visited. Boom, y'all. That's all she wrote. Let's give it a run. Make sure it runs properly before I submit it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted. And look at that, y'all. 21 milliseconds beats -% of users. That's what I'm talking about. I don't know what that dash means, but I'll take it, y'all. So before we go, make sure you get one more look at the code. This is the top part. This is the middle. And this is the bottom part, y'all. And yeah, with that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.